Yeah. Let's start. What was what you put on? Huh? But I told you man, let's start. Thanks, are you hey, nigga, I don't know what. Using up. For me, too, like about too many. So hard is crazy. Hard is crazy. No, but it's good. She was reading yesterday. The cash hard on top. Yes. Yes. Are you lost lyrics? Yeah,
Why would I assume that was the boys that
I'm not saying you. I'm just asking you a question.
Almost.
That was an educated guess. I was being honest.
Someone else representing
Yeah. So I realized literally that at the end of the day, yesterday that
That's very clear. People from other schools it's actually different. Mine is only
Yeah, I know. I wrote made a search. So. Basically, if you don't give us anything for Okay, guys, let's get started. Okay, so when the register comes by today, they gave us a full register, so you have to sign on the side. And also the test, guys, you'll get the test back soon. I should be done by tomorrow. The marking is done. I'm still entering the marks. Everyone's done well, which is good. I think there's only like 2 people that failed out of everybody. Yeah, and it's unlikely there's any of you guys because these are people who didn't write their name properly and it was like no effort made at all. You have to really try hard to fail here. Those people tried hard. Yeah. Like they left out most of the questions and the writing was, I couldn't read what they were, it was like that bad. It was like, I don't know if it was English. Yeah. So it's unlikely to be anyone who made any kind of effort. Even just to get 50 is very easy.
What's that?
People, I'd say average is about 75, 80 around there.
Yeah,
Is there? A few people. Yeah. Probably about 5, 6-ish people got 100. Also, guys, with the videos, they will be uploaded by this weekend. Just give me a bit of time because marking and sorting that out is taking some time. Okay. Okay, guys, let's get started. We are now doing the new learning unit. Did I give you guys an ice task the last time?
Yes.
I think I did. Okay. Okay. Yeah. I gave you a lot of time for that, so. All right, guys, so we're starting with learning unit 4 today, which this is where things get a little bit tricky. So I'm going to need you guys to try to pay as much attention as you can in class for this stuff. Okay, all right, I'm going to need you guys to be quiet, please. I need some silence. Right. Another way to say quiet is stop talking, whatever works for you. All right, so we're starting with learning unit 4, and the first part of learning unit 4 involves counting. Counting not in the traditional sense of counting. It's more like counting very complicated combinations of things. So it's a lot like combinatorics. So give you an example right here. Examples of questions we will be answering in this learning unit is the first bullet point here says in a group of 10 people, if everyone shakes hands with everyone else exactly once, how many handshakes took place? So it's not things you can just immediately think and count in a simple sense. You need to have established methods to answer questions like these. Right, so a lot of these are kind of like brain teasers as well. I won't lie to you guys, I don't shine in this section. I don't like this kind of things. But anyway, it's here. So I'm a maths guy. This is not very much like maths, but anyway, it's here. So we'll have to go through this together. So the first thing we'll learn about is called the additive and multiplicative principles. We start with the additive principle, and we will build some kind of intuition before we get into the principle. So let's see if we can understand things logically. So I give myself enough space here to write, so I'm not sure. Since it's all recorded, let me just open something else where I can write. Make space. Okay. So the first example comes in this first paragraph here, just above the purple box. And let me just read this. It says, consider the rather simple counting problem at Red Dogs and Donuts, which is some kind of cafe or restaurant or something. At Red Dogs and Donuts, there are 14 varieties of donuts and 16 types of hot dogs. If you want either a donut or a hot dog, how many options do you have? Okay, and this is not a very difficult problem to solve. It's like imagining that you look at a menu, and on the menu there are hot dogs and donuts, and you're asked to choose only one thing from the menu. Right? We know there are 14 donuts and 16 hot dogs or whatever. Right? That's another consequence. Yeah. So if you were to pick one thing from this menu, how many options do you have? Can you guys try and figure that out? Right, is the answer here? Yeah, so you just add them together, right? So what this essentially looks like is, oh, I already made space here. Let me use this area. So it looks like is you can imagine a menu here. So I'm going to make a 2-page menu. And on the first page, we have hot dogs. Second page, we have donuts. And all the hot dogs, I'm just going to write a line to represent a hot dog. So that's one type of hot dog, another one, another one, another one. They were, what is it, 16, right? I think there were 16. 16 types of hot dogs, and the donuts menu has ... 14 types. So clearly, if you look through the menu and you can pick only one thing, you have 16 options from here, 14 from here, total of 16 plus 14, which just gives us 30. So 16 plus 14 gives us 30. Okay, guys, this is an important section. Please, I need you to settle down today. Okay. All right, so now that we have an intuitive example, let's look at the principle and see if we can make sense of that. The additive principle, can I show this whole thing somehow? Okay, so the additive principle says that if event A can occur in M ways, let's highlight that part. Event A can occur in M ways. Event A here would be picking a hot dog, right? That can occur in M ways. M here is 16. So if event A can occur in M ways and event B can occur in N ways, we'll cover the word disjoint in a moment. So event B can occur in N ways. That's picking a donut, and that was 14 different ways. So N is 14 in this example. M is 16. Disjoint just means that the two events aren't related to one another. So picking a hot dog and picking a donut are completely independent events. They're not related in any way. Right? That's what disjoint means. Then event A or B can occur in m plus n ways. So picking a hot dog or a donut can occur in m plus n ways, which in this case is just 16 plus 14, which is 30. It's just making a mathematical principle out of something that we learned through intuition. Okay, so I'm going to try to go at the pace that you guys need me to go at in this section. So is this one okay so far? So far, so good. Okay, perfect. All right, so that is the additive principle with the red dogs and donuts example. So I tried to put at least one example per principle. But since we're just starting, we'll look at a second example for the additive principle. So this example says, how many two-letter words can start with either A or B? And the way they define a word here is not like an English word. It can be anything that has two letters. So for example, AA is a word, AB is a word, AC is a word, and so on. All of these are defined as two-letter words. So how many two-letter words can start with the letters A or B? Right? You'll agree if I start with A firstly, if I complete this list of all the words that start with A, there's going to be 26 here, right? Corresponding to the number of alphabets that we have. So here there are 26. And words that start with B, it's the same thing, BA, BB, BC, and so on. Here we also get 26. Right, so according to the additive principle, this is event A. It can occur in M ways, I think. M was the letter they used. Event B can occur in N ways. And the numbers are given here. M is 26, N is 26. Both are the same. So maybe I should write here on the side. Event A can occur in M equals to 26 ways. Event B can occur in N equals 26 ways. Then A or B can occur in M plus N ways. A or B can occur in M plus N ways, which is equal to 26 plus 26, which is 40, 50, 52 ways. So again, here we didn't actually need the principle. We can work this one out in our heads just by counting the number of options explicitly. But we use the principle just to get used to it. So again, this section is going to be a little bit tedious with memorizing things like this. A little bit boring here and there, but we'll try and do what we can. Okay, I'll try not to make the lessons go on too long as well. There's a lot of new stuff. So the next thing we're going to learn is some, I'm not sure, we'll scroll ahead and check. I think it's a multiplicative principle, but let's see. Okay. All right, so the next thing we look at, so we're taking the additive principle and using it to now try to learn the multiplicative principle. So let's learn with the example. The example says, suppose you're going for some milkshake. You can pick one of 6 milkshake choices and one of 4 toppings. How many choices do you have? Again, let's start with intuition before we look at a principle. So we have 6 milkshake choices, and for each milkshake choice, we have 4 toppings. How many options does that give us in total? We can start imagining it literally as milkshakes on a table with all the toppings. Imagine you're looking at all the options and we count them. Let's see how many there are. So I'll draw a milkshake as just like a glass here. And I'm not going to draw whole milkshakes. That'll take too long. That's one milkshake. We have 6 of them. 1, 2, 3, 4, 5, 6. And for each milkshake, we have 4 toppings. So from here, we have the option of, how should I draw a topping? I'm just going to draw it as a circle. Be a marshmallow, sprinkles, whatever, it doesn't matter. So we have 4 options each. 1, 2, 3, 4. So this circle represents this milkshake with topping 1. This circle represents that milkshake with topping 2. Next circle, and so on. Different milkshakes. Same milkshake with different toppings. That's all of these, right? The next one will be the next milkshake with 4 different toppings, the same 4 toppings. And this is a bit tedious, so I'm just going to fill them all in so we can check what happens explicitly. 1, 2, 3, 4. I really don't like this section. But anyway, so I think if I make any mistakes, guys, just check what's happening because these things really confuse me sometimes. Okay, but here I think it's clear that here we have 4 options. From this milkshake, we get another 4 options. From each one, we get 4 options each. Right, so from here, we get 4 options, another 4 from here, another 4, another 4, another 4, another 4. Right, so just adding all these together gives us all the possible options that we can get for 6 milkshakes with 4 different toppings. So I'll just add them together. That's not good. Add them together, and then this will give us, let's see, 24. Is that right?
Correct.
Yeah. Okay, perfect. All right, and this is where we now go on to the multiplicative principle, which says, okay, let me not give it explicitly just yet. Basically, if you have, more colloquially speaking, if you have a group of something with 6 possibilities or a certain number of possibilities and another subgroup corresponding to that with a certain number of possibilities, just multiply those 2 possibilities together and you'll get your answer. So 6 possibilities times 4 possibilities will give us the same answer here, 24, right? So that's 6 times 4 gives us 24. This here is using the multiplicative principle, which we'll look at explicitly in a moment. Okay. And because the section is a little bit confusing, I'm trying to give at least one intuitive example each. So if we forget the thing, we'll just go back to what we understand, the intuitive example, and then from there we try to work back to the principle. Okay, so that's what does the principle look like? It should be, actually, no, I remember this one here. For some reason, I didn't copy and paste the principle onto the notes. So I'll go to the module manual to get it. Module manual. This is it here, right? This should be in the notes, but it's not. So I'll cut and paste this and re-upload the notes at some point. But this is the principle right here. It says that if event, what was the thing? The multiplicative principle states that if event A can occur in M ways, event A is picking a milkshake in this case. So M here is equal to 4. And each possibility for A allows for exactly N ways for event B. N ways for event B, that's picking a topping. So that is, we had 4 possible toppings. I think the milkshake was 6, right? My mistake. It's not 4, it's 6. Then event A and B can occur in M times N ways. So just multiply these 2 numbers together. 6 times 4 gives us 24. So this is one of those things, again, it's hard to take everything in class. You have to go back and just try and do it by yourself a few times. That's the multiplicative principle. I'm going to torture you guys too much, but unfortunately it's only been like 20 minutes, so I can't stop just yet. Not even 20, we started late as well. So.
Like 10 minutes.
Like 10 minutes, yeah. Okay. So we've done only 2 principles so far. So I'm not going to torture you guys with another example of the same type. I just want to show you this example here very quickly. So we can, okay, guys, please. We can generalize this example to more than one layer of options. So for example, if I had something like, you could pick 3 different milkshakes. For each milkshake, you could pick 1 topping. For each topping, you can pick from 2 types of marshmallows. I don't know, something like that. You keep on layering the options. And if you layer the options, you just look at the number of options per layer. So first we have 3 milkshake choices, that's here. We have 2 toppings and we have 2 marshmallows. So the number of options you can make will be just these numbers multiplied together, 3 times 2 times 2, which is 4, 3.12. That's 12, right? 12 different options. Okay. Sorry, guys, we don't mind. I'm trying to teach. So it doesn't matter how many layers of options we have. What you end up doing is just multiplying all the options together. So let me see if I can make an example that will appeal more to you guys. Let's just make one here. Let's call it example 3.3. Suppose you have, I don't know, you're going to different dealerships. You can go to McLaren, Lamborghini, Porsche, whatever, right? Different dealerships. Let's say we have 3 dealerships. For each dealership, you can pick, from each dealership, you can pick from, how many Lamborghinis exist currently? It must be like 3 or 2 or something. Can't be too many. Like the current ones that would be for sale. Forget the new one, Centenario. Aventador is out of date now, I think. Imagine. So I'm just going to say that there's 3 different models each. 3 models. For each model, I don't know. You can pick either petrol or diesel. Diesel, petrol. They have diesel Lamborghinis now, I think. And for each thing, you can pick, I don't know, 2-door or 4-door. 2-door, 4-door. And for each of that, you can pick airbags or no air. No, you can't do that. It's not working. Another option, I don't know. Colors, yeah. Let's say you can pick, let's say 5 colors. Okay, so if this is the list. Sorry? Yeah, we can't do that. Tires. Okay, let's do that. Tires. How many tire options we have? We're looking at each one. 21 inch, 22 inch. That's too many. Can we just say 5 types roughly? 5 different types. 5 tire types. This woke you guys up very quickly. Okay, one more subgroup. Engine. Engine type. Let's say 3 different types of engine. Shall we exclude electrical from that because that will ruin the sound of a Lamborghini? Okay, no, we're all about saving the environment, guys. I didn't say. Who needs V12s? Okay. I do not endorse this message. Okay, so if we have this amount of subcategories, then how many options do we have is simply by multiplying the number of possibilities of each category. First category, let me change color for this. Basically, how many different car types can we end up with? How many choices do we have? Well, we have 3 dealerships, so we start by saying 3 multiplied by 3 models, so multiply another 3. Diesel or petrol are 2 options here, so that's another 2. 2-door or 4-door is another 2 options. That's 2 there. 5 colors, we multiply by 5. 5 tire types, multiply by 5. And 3 engine types, multiply by 3. You got something there. Sure. 2,700 different possible cars. That's insane. Thank you. Okay. Right. So forget about all the intuition we did in the beginning. It seems straightforward, right? Just multiply the number of options for each subcategory, put them together, and you get the number of possible options at the end. So, how's our time? Half past. Can you guys make it till 10:45? We're surviving. Okay, so keep in mind what we just looked at. This example here should become simple. Right? This example says how many license plates can you make out of 3 letters followed by 3 numerical digits. Right? So for this, I'm not going to abandon you guys and make you try this by yourselves just yet. We can think about it together. Let's think about what a license plate looks like. And we have 3 letters and 3 digits. So let's make 6 slots here. 6 slots. We said that the first 3 can be, why can't I see this thing anymore? Letters, right? The 3 letters. So we have letter, 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 and a number, number, number. To be more specific, a digit, right? So anything from 0 to 9. Okay. So you guys agree with me that for letters, we have 26 options. Right? For every letter, we have 26 options. For every number, we have 10 options. 0 to 9 is 10 options. So for the letter here, we have 26 options here. Multiply by 26 from the next, multiply by 26 from the next, and then 10, 10, and 10. Right? And you got an answer for me. Okay, that's a nice big answer. 17,500. Sorry, 570. Thank you. 576. 17 million. Okay, thank you. Right. Okay, so you agree with me that using the multiplicative principle, these examples now become easy. Right? But if you have to work it out in your head, this is quite a difficult thing to do. Because if you worked it out like the milkshakes example, it would be complicated. It would be something like, for the first letter, you have 26 options. So that would be A, B, C, D, all the way. And for the A, you have another A, B, C, D. All these are options. For each of that, you have another A, B, C. It gets crazy. Right? It gets very long. So you could do it this way, like we did with the milkshakes, but it's not necessary. It becomes terrible. And I think one of the points they want to make in this example is you can now simplify these using power rules. So this 26 times 26 times 26 times 10 times 10 times 10 can be written as 26 cubed times 10 cubed, right? So you can simplify it that way. Just take note of this form here, because it might be a stupid thing asked in the exam. Simplify using the power rule, and then after that, write an answer. So we don't want to lose marks for nothing here. Like many people did in the test, unfortunately. People just don't follow instructions. So guys, pay attention to these finer details, because if it says something like in the test, one thing said write as an improper fraction, people left it as a mixed fraction. They did extra work and lose marks for nothing. Right, so just be aware of these fine details. Just read the question. Okay. All right. But again, I gave most people the marks, but again, if it gets moderated, we're in trouble. So let's just be careful, because exams are probably moderated. Okay. Okay. Sheesh. One more example. Yeah, sure. No problem. Any questions before I move on? Okay. Just unfortunately boring stuff that we have to remember. Okay. Now this is where it gets a little bit tricky, and this one confuses my brain sometimes as well. Let's be careful here. How many functions of this type are there where we're given the domain and codomain? How many such functions exist? So understanding the question is the main thing before we actually get the answer. So what would one function like this look like? Let's try and imagine it. So remember, a function is just a mapping from every element in the input to every element in the output. Domain, codomain. So like you could have, just as a possibility, you could have something like F1 is mapped to A, F2 is mapped to A, F3 is mapped to A, 4 to A, and 5 to A. Like this is one possibility. This is one possible function. This entire thing here represents one function. Okay, another possibility would be F1 to B, F2 to A. But I'm just going to write it out. F3, F4, F5. So this is another possibility. I've changed only one thing here, but it's another function. So this here represents one function. This here represents another function. I'm going to say the second function. Let's call this one here the first function then. Okay, and there are many possibilities like this. So the question is asking us how many functions like this exist. Shall I give you guys a moment to think about it before I do it? Yeah, I'll give you guys a few seconds. Just think about it. Maybe I should do the same.
I can keep a mind.
Okay, so guys, the way we would work out something like this is, first let's get a picture of what's happening. So let's see the first input here, f of 1, we have 4 possibilities to map this to. Those are A, B, C, and D. So let me make a little diagram here to show that's A, B, C, D. 4 possibilities we could map that to. And for each of these possibilities, we could map f of 2 to the same possibility. So I'll write it like this. F of 2 can then be mapped to A, B, C, or D. The same is true here. F of 2 can be mapped to A, B, C, or D. And we just keep on building this, right? I'll just do one more. For this, f of 3 could be mapped to A, B, C, or D, and so on. It's just a visual way to represent this, which you don't have to do, but just to get an idea and to see what's happening and to make sure that we understand this is similar to what we did before with the number plates example. Because if you follow one branch, for example, all the way down, you see it gives us F1 is A, F2 is A, F3 is A, and so on. So one branch all the way down represents one function, right? So in other words, every branch all the way to the bottom is given 4 possibilities, right? So we have 4 possibilities per input in the function, right? So for the input 1, we have 4 possibilities. For the input 2, we have another 4. For 3, we have another 4. 4, there's another 4. And 5, there's another 4. So it's just like the number plates example, where we just multiply the possibilities together. And this will give us 4 to the 5. So there are 4 to the 5 possibilities here, right? Whatever number that is, that's calculator work. You guys can check that. But it looks complicated with this diagram. But when you understand, when you just look at this, just like the number plates example, they are the number of outputs. There's 4 of them. The number of inputs gives us the number of, basically, the number of the power here. I'm trying to make it seem okay, but this is a terrible example. I also don't like it, but it's one we have to remember. Counting on sets, okay. All right, so now we're going to take what we learned and implement set theory into the thinking. Okay, so you guys all look like you need coffees or something. Is it a day like that? Okay, so guys, what I'm going to do is maybe I should give you guys a bit of extra long break so you can go order something, have a refresher. 20-minute break, but be back I'm starting at exactly 11 since the break is long. All right.
Mga days. Hey.